Hi, so let's see how it's doing. So as you can see, there's some distribution there. So, but Mufa is doing okay. So let's check out the answers, and then we will see if we need to discuss further. Okay, so I think we can go to here. Can you see the my notebook? Can you see the question? Yes. So let us discuss, go over the questions one by one quickly. Should not be a terribly difficult thing to see. If n equal to 250, determine the mean age is greater than 30, population is variance less than 5 years, and sample is, so let's write down what is here, and 250, okay, and 1 to c is greater than, then this is mu is equal to 30, and mu1 is it greater, so is it greater than this, okay, and this is the sample mean, which is 30.45, okay. So this is one sample test, right? It's asking whether you know the standard deviation population 1, which is 5, okay? So you can use z-test, which is the sample mean, right, minus the proposed population mean, right, and divided by 5 over root of n, which is 250. Okay, so that is the question, right? And if you do the subtraction, then you should be able to see it should be 1.42, okay? And do note that in a Z space, right, we know Z space, okay, with mean 0, right, and what we have is 1.42, and we can calculate p-value, right, by looking at, because we're rejection on the right, so it is area like this. So what is this? This is the p-value, right? It's probably that z is bigger than 1.42, so which is 1 minus norm dot s, right? Dot this 1.42 should give you the answer of 0.077. So it should be answer B. Is that okay for the first question? Good. So go to the next question. The coffee shop owner recently surveyed n equal to 100. Okay, n equal 100. Okay, we determine or not the mean is less than, so it is h now. Mu is equal to 25. H1 mu is less than 25. So rejection on the left is a left tail test. And the sample mean is 24. And the sample standard deviation S is 5. Okay. So since we don't know sigma, so we use T, right? T of, then will be 24 minus 25, right? Over 5 over root 100. Okay. So it's negative 1 over 2, 1/2 is -2. Okay, so go back to the question here. We have t, this is a 100, so it's t99. Okay, it still means 0. Still here. Okay, and -2, so it's here. Okay, so we're just asking, is this area is the p-value? Right, because why? Because of rejection on the left. Okay, so the probability that t99 is less than 2. Okay, so we just t this, because left hand side, so t this, -2, degree of freedom is 99, and true. Okay, so that should give you 0.024. Okay, so the answer is B. Okay, question 2, is that okay? Why T? Because someone asked me why T. The reason is you only know the sample version, not the population, then you have to use T. So that is different between Z and T. T is used when you don't know. The quiz is just for attendance, yeah. People ask whether the quiz result would affect, yeah, no. Just, if you attended, you do it, then you get it. Yeah. Any further question? The standard deviation is the sample one, not the population one. The population, then you use normal. Is that clear? Yeah. Someone asked me question 6, I'll answer that later. Let's go one by one. So question 2, I think is okay, right? So we go to question 3. So you can check back and get back to me if you still have question. But we use T because of we have no idea about the population standard deviation. That is the trick. Here, asking the revenue is this one, and standard population is this one, okay? And as audit, and then someone claim the sample is like this, okay? Sample is 625, okay? And you have standard deviation, but not the mean. So we actually know the sigma is 75, okay? And we can use this one. So you need to test the hypothesis that mu is 650, right? And is, right? And also we don't know, so it must be the case this is not equal to. So it will be a two-tailed one because you don't have any particular information that is naturally two-tailed, okay? And also explicitly ask he was, and also from the question is not auditor, then you want to make sure that it's exactly or not. So that several evidence that you should do a two-tailed. So you know this, then you use Z, okay? Then is forget the N, and what we have is 30 days. Okay, so it's 625 minus the mean over sigma over 30. Okay, so the answer should be equal to -1.825. So again, let's look at what the diagram is said. The Z is here. And again, this is 0, a bell curve, okay? This is negative 1.825, okay? Remember, we are doing two-tail, so the area we need is this, and also this one, right? It's 2 times of that, right? So it's the P is equal to 2 times the probability that Z is less than negative 1.285, right? So it's 2 times norm S this negative 1.285. Okay, you put the true, of course. Okay, so the answer would be the p-value is 0.679. Okay, so the p-value, because you need both. Is that okay? Any question? Here I use Z because we know it, otherwise we use T, right? Okay, okay. Any further question? If no, then we go to the next question. Here we have question 4. We said knife of our doctor set the plate, recommended aspirin, and then you want to text a claim whether it's less than, right? So it's very clear that what you see is pi, the proportion, population proportion is equal to 0.9, and the other case is pi is less than 0.9, okay? And the data you have is 100 doctors who recommend 83, so n is 100, and the data you have is 83 because 0.1, right, the sum of x. Well, someone asked me why I don't need the 1 minus, because I put a negative 1. The same thing. Is that okay, Hui? It's symmetric, so you can put negative and the same thing, okay? So P will be x over n, so the sample proportion is 0.83, okay? So we want to see a test statistic for this, right? And we know this is normal, right, already, with the mean, this, and the other one, right? And then this, okay? So Z will be 0.83 minus 0.9 over, because you are assuming this is true, so the variance is like this divided by 100, okay? And this would be negative 2.33, okay? Is that okay? Is the Z1? Any question? If no, then we go to next question. So you have 2 sample with sample size 16 and 5. Sample variance is 4. And you do a pooled variance, right? Pool the variance means you pull together, then the DF will be just n1 plus n2 minus 2, okay? Will be 16 plus 25 minus 2, right? So will be 16 plus 23, right? Then it's 9, 39. So it should be B. I guess there shouldn't be an issue here. Okay. And next. So people ask me why this is 36, but I would I will just, the reason is you apply the formula, right? This is the V will be something like S1 square over N1, right? Plus S2 square over N2 square as numerator, and denominator will be 1 over N1 minus 1, right? S1 over N1 square, 1 over N2 minus 1, S2 over S2 square over N2 square. And once you calculate, you are rounding down. So round down, remember we are rounding down. So we get 36.56. So turn out you have 36, okay, instead of 37. Because round down. So the reason why it's round down but not round up because of if you put a smaller degree of freedom, then it's less likely to reject. You're more conservative, okay? Because as you do, usually we put something on the proof in the alternative, right? So that's why you really want to reject a null. So that's why we are more conservative, though you take the smaller one, okay? So that's why you take the smaller degree of freedom instead of the bigger one, okay? So clear the drawing. I guess I should change the number that I think that fitting your data. I think this is what I rewrite in the in your answer, right? So let me change it accordingly. Okay. Why Q5? No, I'm asking to pull the variance test. They can have, well, even though they have the different sample variance, but they can, you assume coming from the same population, have the same variance. This, when you do sample, it can be anything. Is that okay? I mean, when you do sample, it can be anything, but you can assume underlying is, can I explain Q3 again? YC not D. Why not D? Oh, it's 6.79, so it's not 789. Is it NJ? Is it the question? So question about why, oh, the answer is 0.678, so it's not, should be the C, not D. Is that okay, NJ? You've been this one? Maybe I'm wrong, but let's check. Let me check that. Is it the case? Then should be known as this 1.25. No, yeah, no, I did get 0.6. Yeah. Maybe you should try, maybe if you have confused, you can try this again. Yeah, to give you something close to what I've said. Okay, for the question 3. So there's a question. Yeah, what a question. There's no more questions. So question 6, we are done. Question 7 would be something not terribly difficult because of they have asking the difference, pair the difference. So we just n minus 1, which is 19. Okay, I don't think I need to explain further. So I think that there's still two questions. This is a question about different in proportion, right? Okay. N1 is 50, okay, and N2 is 40 here, and X1 is 11, X2 is 19, so P1, which is 11 over 50, is 0.22, I guess. P2 is 19 over 40. What's the answer? Is 0.475. Okay. So the question is, the null hypothesis would be whether pi1 equal to pi2, because claim they're different in attitude, right? So they don't tell you which sign, then it should be pi1 not equal to pi2. And the z, because this is a fraction, is a proportion, so it's 0.22 minus 0.75. Okay, and the thing is, you need to use the pooled proportion, right? So in this case, the pool one would be equal to x1 plus x2 over n1 plus n2, so which is x1 plus x2, that is 30 over 90, okay? So it's 0.333, so it will be 0.333, 1 minus 0.333, okay? A little bit longer for the denominator, right? It's 1 over n1, which is 50, plus 1 over 40, right? Yes, I think that is the way we calculate, right? So that end of the answer is negative 2.55. Okay, so the answer is A. Okay, so here we come to the, okay, here we come to the very last part. It's the F test, here variance. So we said with sample size 16 and 25, sample variance 4 and 9. So N1 is 16, N2 is 25, S1 square is 4, and S2 square is 9. So F will be S1 square over S2 square, right? It's 4 over 9, or S2 square over S1 square, which is now 4, right? This is 0.44444, and this is 2.25, and this doesn't exist, but this here, so we put this one. Okay? So you can do one way or the other, right? So you didn't, just fine. Okay. If there's no further question, let's have a break of 15 minutes. So there's a question, but if let's have a break, then we answer the question. Let me answer the question during the break. So let's have a break first, and then so we will resume at 5:41 p.m. So there's a question for question 7. What if N1 and N2 are not same N? You can't, because it's a pair difference. You must be the same. Oh, I erased too fast. Because so another question is how I get 2.25, right? Because F is either this, so either this, or you depends on what is first or second, right? So this is either 4 over 9 or 9 over 4. Okay, so it is either 0.44444 or 2.25. It's 9 over 4. Can you see the screen? You see it? Just 9/4. Excel, there's no Excel, just 9/4. There's no 9/4. 9/4 is 2.25. There's no Excel involved. It's just divide. It's just a division. Because the formula is just a ratio of variance. There's nothing more than that. Is that okay? Someone asked me to explain again question 6. Question 6. So what's the question? Just plug in the formula. Just V is equal to S1 over N1 plus S2 over N2 square over 1 over N1 minus 1, S1 square over N1 square plus 1 over N2 minus 1, S2 over N2 square. So this formula, and once you calculate, that is 36.56. Remember the functions run down, okay? And you have this is just 36. Common is okay. So just this, you always get the round down function, the floor function. I think you see this floor function when we talk about the interquartile range, right? Q8. So someone asked me Q8 again. Is it? So yeah, let me check. Since you have asked, let me check my Excel for my sign. If this formula is right, then you maybe you can check from your side. Just input this in your Excel, then should be the answer. Hi, welcome back. I guess I should talk about the announcement I make in the in the Blackboard. So just to let you know, because we finished the hypothesis testing, homework 4 will be given. You are given 2 weeks to do it, so it'll be 20th November. That will be the deadline. So it will be this has been uploaded. Will be deadline here. So I think homework fee is a deadline of 30. Okay, homework fee, right? Still have deadline, and the next homework will be ANOVA and regression. We'll give you deadline at the when I finish the topic, and because we combine homework 5 and 6, right? So we have one less homework. So let's make the peer review homework 1 to be the which has deadline of next Friday to be the homework 6. So if you have done it, then you are done homework 6. If you have done it, make sure you have done it because it's part of your homework. Okay. And which I'll go over now is the project. Probably you will notice uploaded in the assignment too, in the assignment of the black box. So it will be a written report by the end of this course, and we will do a in-class presentation, and you will do a peer review during the presentation. So we will fill in the form. Some question. Is it typed wrong? Oh, it's December. Well, good question. Should be December. Yeah, December. Sorry, it's the last week of the December. Sorry. Oh, I put it should be December. Is that okay? Yeah, I think that one is a typo. Let me change it. Sorry for that. Let me do it now to make sure that we don't should be December. Sorry. Yeah, it's similar to assignment 1. I'll go over that now. Let me go over that. It's similar to assignment 1. Assignment 1 is focusing on the assignment 1 is focusing on the descriptive statistics, right? Now we are talking about the statistical analysis. Okay, so let me. And people ask whether it's group or individual. It can be group individual. So it would be like this, because in the syllabus I said I allow group or individual, so that's why I would allow you to be in group or individual. That's also fine. But the work is proportional to the size of the group. So this is already uploaded. What I need to do is to do inference. Okay, the first assignment is focusing on the descriptive. So for this is meaning this several things we are going to cover. So we cover estimation. We are just finished hypothesis testing. Today we will talk about some ANOVA and there was some regression. Okay, we'll talk about that quickly. And you can do all the same. So you will be, if you one person, you do one page limit. If you have 2 people, then 2 pages. And the presentation will be proportional to your group size. If you have 1 guy, then you have 2 minutes. If you have 2 people, then you have 4 minutes, so on and so forth. And the deadline is 4th of December. I think this is correct. You also declare in the same way that I think in the same spreadsheet we do in the as we do in the as we are doing that in the assignment 1. So it's another spreadsheet. So let me show you. So this is the spreadsheet. You do the assignment 1. Look at the below tab. There's a project. So you just you can declare the same topic. Can be different. Can be same. Can be different. You can do the same. Can be different. You can do it in group. Doesn't really matter. Just try to illustrate your skills. I don't restrict you are doing the same or different. Just make sure that you're different from others, just to make sure that to avoid plagiarism, right? Because if someone delete your topic, then you should be let me know, because Google already record everything. So you can let me know, then I will try to resolve the problem. If you put in first, then you have a priority. Just let me know if someone delete your thing. No one should delete your item. That's why I do the Google form. Is that okay? Yeah, you can form it with section A, but the fact you make sure that your presentation of your group mates will be there. Of course, there'll be assigned a time for you, but make sure that you're there. I think it's fine. That's only constraint for the in-class presentation. Assign a time, then you should be there. Okay, because okay, so you would be make sure that you write your group name, student name and student ID and email, and because in case of the emergency, you write your section A or H, and then you write a topic. Okay. We'll do it in the very last two classes. Okay. That is for this one. And the other thing I need to talk is the yeah, one person group is a group name same as yeah. Or you don't need to write it. Yeah. If you happen to only submit the video only if you are in the time zone problem, you will present in class, unless the video will be in class, you present it in class, unless you are not in the same time zone as Hong Kong. So you have a legitimate reason not to attend. Otherwise, you should be presenting through the Zoom. Yeah, you present with your camera on. Yes. Well, yeah. Otherwise, I don't know who is presenting, right? Right, because you present with camera on yourself to make sure that this is you presenting, and that's it. Just like what I'm presenting, you just do the screenshot, right? Just like you do the PowerPoint and thing. Peer review will be just same as the peer review of that. I'll give you the form, then you will just fill in. So we'll include the color. It's part of the assessment too. So you write down the comment. You give your comment, both qualitative and quantitative, on the presentation. Is that clear? So you say this is about fair rate life calibration, then you say, oh, you do it on spot. You do it on spot. So you do it, and then I give you say 1 or 2 minutes, and you write that down, and then you submit. You do on spot. So you don't need to. It's not. Then it's not. When you know the result, please assignment. It depends on the TA. TA's grading. I think he's grading quickly. I think the homework 1 is already done, and the 2 is almost there. I think he'll upload both of them together to you. But homework 1, I need to. It's just that I can just give you the grade of the TA. For the peer review and my grading will be, I need to combine later. But you know the partial result for homework 1, because the peer review is not collect yet, right? So I cannot release that, and I don't want to release my grading before the peer review is over. Okay. Any other questions? Just to remind you that the text will be 7:30 to 9:30 on 26th of November. You'll be done Zoom, unless you have prior approval from me that you can absent because of legitimate reason. You have to attend. Okay. Otherwise, you get 0 for that particular one, and you will be there will be no multiple choice. All are the short questions. There'll be 9 questions in total, and then for sample question, you can check the I already uploaded what I found in the library, so you can go to the Blackboard and check. You can imagine those are sample questions because my question will not deviate from that. Oh, it's already there. The Blackboard is already there. I uploaded already. I see it. Oh, I forget. Sorry. I'll do it. I'll do it. Sorry. I think I missed that particular file over there. Will do. Just wait a bit. Yeah, I will do. Let me do it quickly. Just wait a second. I will do. What's it? I thought I uploaded already. Sorry for that. So what else are the questions? I think I forget to upload for this class. Yeah, should be there. Yeah, let me know if you have any further question. So if no, then let me quickly go to any more question. Just make sure that the homework will be due the next Friday for homework 3, and then homework 4 will be on 20th. Okay, I hope you remember your deadline. I mean, just make sure that you don't forget your deadline. Okay. So let me very quickly talk about the ANOVA. We just give you some introduction. We don't have time to go over a lot, but at least give you some idea because you may be doing the project, preparing the project, but so shouldn't be a big issue. So let's talk about ANOVA, but so we're doing the ANOVA. Okay, so we're doing ANOVA, analyze of variance, somewhat we call ANOVA. Okay. To start, let me talk about the rest of this course. Give you 2 to 3 minutes to talk about what the rest of this class, rest of the classes is about, because we have left 2 things, ANOVA and regression, right? So you may be curious what is left in the remaining. Let me, I think we're good to open a whiteboard and talk about that. So what remains is 2 topics. One is ANOVA, one is regression. Okay. For us, actually, it's a very related idea of you talking about relationship of 2 variables. Okay. So actually, we also talk about relationship of 2 variables when we talk about the 2 sample hypothesis testing, 2 sample tests. Why? Suppose, remember we have, say, look at, say, in the quiz, right? We have discrimination and no discrimination among male and female, right? I have a question on that. Or it's a sample proportion, right? And it's a variable within gender, right? And discrimination. Okay. So here we have 2 categorical variables, right? Either you're male or female, you think there's a discrimination and there's no discrimination, right? So there's a 2 variable that is either 1 or 0. Okay, one way or the other, right? It's like binary, 2 binary variable. Okay, so now we no longer talk about 2 binary. Okay, there's a binary here and binary there. Okay, then we know how to test whether the grouping would, whether the discrimination would differ by gender, right? And now we are talking about another thing, is talking about ANOVA. Is you can imagine we're talking about a continuous variable over a binary variable. Okay, how they're related. Okay, you can imagine that it is a salary, okay, and gender. Okay, salary is continuous, gender is discrete, right? You want to see whether income or salary is different by male or female, okay? Whether there's a gender discrimination, okay? Or I look at the GPA, okay? Its GPA is going to be different by gender, okay? But this is what ANOVA is, okay? Whether grouping will make a difference, right? It's a continuous variable and we'll try the difference. And it's more general than two sample, two category. You can have multiple category, right? For example, you can check how GPA is different from marketing student, accounting student, finance student, okay? And whether the major affecting the GPA, right? Then there's a grouping. Whether grouping would make the variable we measure is different, right? Whether grouping would make difference. So this is ANOVA. Okay, this is something we talk about. And regression will be, instead of a binary, you are looking at continuous versus continuous. Okay. One example, one common example you can imagine in business application is you're asking whether advertising, how it changed sales. Okay. And usually what you do is you have a scatter plot, right? Look at sale, look at advertising. Okay, look at advertising and sales and how they're related, right? We actually talk about this in the chapter. In the first topic, we talk about scatter plot, right? We put a line there, right? So that is whether advertising actually helps sales or not, right? Can be here, maybe negative, right? Sometimes you do advertising in the wrong channel and people may hate you, right? So that depends on whether you do it correctly or not, right? You ask. So that is the rest of this course. For regression, we only talk about the relationship between two continuous variable. Okay, and if you want more and more and more, then we rely on more complicated technique. It's called multiple regression. This is in the textbook, but we don't cover it. It will be left for you for another class. I think it's DSME 2021. I don't know, or 1.2 or 2.1. I don't know. It's like correlation, but regression is actually you give a formula. You come up with the formula sales is equal to alpha plus beta from advertising. You're estimating this directly. You come up with a linear equation. So this is the regression. It's like correlation, yes. But we have more thing like we'll do hypothesis testing on beta and alpha and all this kind of thing. But this will be the last 3 classes. But that is something we will cover, okay? But you can, if you're curious, you can check the video ahead, but we'll cover it slowly. But today what we do is do not over, just look at how the binary variable like gender or location would make a difference. Let's suppose you are a food chain store, you want to see whether the food chain store will be different in different area, right? Is Hong Kong Island making more profit or Kowloon making profit or New Territory making more profit? So this kind of questions. Okay. If there are no further question, let me quickly talk about the ANOVA. Okay. ANOVA, as I said, is rather grouping. It's group the data where the grouping would make sense. Okay. And in this topic, there usually a one-way ANOVA or two-way ANOVA. One-way ANOVA is just one type of grouping. It's like gender is a one type of grouping, okay? And there's only one type. And what is two type of grouping two-way is like you have gender and you also have major, right? So maybe you can look at each observation, you're male or female, or then you can look at whether they are major in finance, major in accounting, right? Then look at whether the GPA, whether it would be differ by male or female or whatever, okay? The two level grouping. Each observation would belong to one group of the gender and one group major, okay? There's two way, but we focus on one way today. Either the grouping is gender or the grouping is major. Okay. I hope that's clear. And then we want to know whether the grouping would make a difference. Okay, but we'll be more clear about the hypothesis we are talking. Okay. So as I said, what you have is a group of data. Okay. And for group, sometimes refer to factor. Okay. So the observation you have is a variable X, like GPA or your income. Okay. Factor, usually, as I said, is gender or your major. Okay. And factor, usually you have a variable, either you put it gender is 0 is male, 1 is female, or vice versa. Major, you may put male or F, right? Number doesn't really matter, right? 0 and 1, maybe this is finance, this is accounting, and this is marketing, and so on and so forth. But it doesn't really, the number is not meaningful. It's a categorical, right? It's not meaningful, but just some coding, okay? So that if you add data point, right? For each data point, you know, here's group, right? It's a group of data, data with group. So you will be with one observation, say GPA, then look his GPA, then know which group he's in, okay? It's either 1 up to C, okay? Here I have CO1, but maybe I should be more consistent with my handout. It's 1, 2 here with 1, 2, 3, okay? So 1 up to C, okay? And the data usually you would, is not two-dimensional sometimes. Sometimes you represent sorting together in a single line, okay? So you would be X11 will be X11 will be the data which represent in group 1, okay? First observation, okay? This is the symbol what it means, okay? So that will be group C, second observation. Okay, so that is the notation it means. The first index is the group, second index is the observation. Okay. Now, this is usually what the notation means, but usually what you have is the following. Okay. So what you have is like this, the data. Okay. Say you have male and female, for example. Okay. Or maybe it's better because it's better to use 3 category, right? Because I want to give impression that it's actually can be more than 2. Okay, can be finance, accounting, and marketing. Okay, and maybe the first observation is the GPA, right? Maybe 3.3 and 3.42, and this is 3.31. This is 3.6. This is 3.9, and this is 3.7. But they need not have the same number of the observation. Maybe here we have 3.5, maybe 3.8, the 3.72. Okay, so each group have different observation, right? You may call this group 1, group 2, and group 3, right? So this is N1 is equal to 3, N2 is 2, right? N3 is 4 here. Okay, so this is the data you have, right? For each grouping, your observation is listed in this order. This is usually you will see the Excel spreadsheet. Is that okay? Do you understand the data we are dealing with? Is that okay? If okay, can you type okay? Because I'm not sure everyone is here. Okay, good. Thank you. So quickly to the model, because it's actually similar to what we see testing whether the mean are the same, right? It's just basically very similar to the idea of testing the mean, okay? 2 sample tests, but we extend to more than that, okay? And this is the classical model, okay? What it said is each observation, you see this kind of formulation in regression 2. It said for group I J observation, okay, this is group I J observation, okay, or observation J, okay, and will be equal to the mean of the group mu I. So this is mean of the group I, okay. This is unknown. We want to know what it is. We want to estimate of that, but this is something we want to, this is the model we stay. So this is mu I, and this is the zero mean error. So which means the expected value of this is a random, this is a random variable, will be 0, okay? And this is not a random variable, okay? This is a random variable, okay? There's no variation of this. This is unknown, but this is the random variable, okay? This is unknown parameter of the model. It's a population mean, somewhat, okay? And the model can be further broken down in the following. So this overall mean, this is a grand mean, or the overall mean, okay, will be equal to mean of the group plus alpha. Alpha can be positive, can be negative. It's cross treatment effect. Why that's the case? This is a standard idea of drug test. You do different drug, you see whether drug there's a difference, okay? And if there's no different, treatment effect will be 0, right, on average. But that would be the idea. And let you see the, I think, next slide, and you will see what is the hypothesis we're looking at. So that will not come surprising. It's asking whether group would make sense, right? Different in group, okay? So it means that every grouping, the mean of group 1 should be same as group 2, should be going up to group C, should be same as the grand overall mean. Okay, so if you say so, equal to same thing, then there's no treatment effect, right? It's 0. Why we care about this? For example, experiment in the drug. So you give patient different medicine, okay, and then you see is the medicine recover faster, right? They have the same treatment effect, right? Or there's no extra treatment effect over there. And by marketing, you say different country are different, okay? So does it normal? You can assume normal. Yes. Someone asked me whether this is assumed to be normal, 0 and sigma. Yeah, you can assume that. With this means 0. Normally with 0 mean. Say just expectation is 0. Okay. And in particular, you can also assume assume they have a 0 mean. It's called error term usually. You will see also in the regression.
就係佢哋係咪代表話佢係咪 definition 係一個 mean of group I， 跟住再加一個嗰個 error 係 zero mean 嘅 run？
冇錯，就係咁。
即係佢係 definition。
So this definition, we define the model. So this is the model we define. We define this way because it's not 0 mean, you can put it there.
咁佢嗰個IJ 咧，佢係 normally distributed。佢嗰一句係咩意思啊？即係佢係
This has normal distribution with mean 0 and some sigma square.
OK， 唔該晒。
But I guess we don't need to go to the assumption part because this will be beyond the scope of our today. But you just need to know. That's what we're going to check. Okay. So for the rest or few slides, we just give you some definition, and that will tell you how to test this. Okay, I don't think we have time for the proof. We'll talk about proof next class, but this is the null hypothesis. Okay, this is the same. They have all same mean, and we want to see they are different, right? Because do recall that we have the same when we have t, right? The t is here, but now we need more, mu3 and mu4, all right? So we have more, and instead of t, we have to use f. Okay, so that is the extended model here, and you may imagine that we have all this stuff. In all this stuff is actually also underlying in the model we have in the two sample text, in the same model, but we didn't specify explicitly. But that would be the F test. Okay. So here what it is we give you the grand mean. Grand mean is we have x1. Sorry, we have group 1, group 2, up to group C, right? The first observation is 1, 1, 1, 2, up to 1 and 1, right? Will be 2, 1, and so on and so forth. Okay. So what the grand mean is, you add each single observation and divide the total number, which is n. Okay. Let's read this. You start from group number 1 up to group C. So you roll across the direction. Okay. Maybe I use other color. This is, you are rolling all this direction. Okay. You go from 1 to C. What you're doing is you go from the first observation in group I until the end of the group. Okay. So you're going. Here is, you go in this direction. Okay. You add each observation divided by total number of observation. Okay. And next is summing all the observation divided by its group mean. Okay. So basically what it's doing is, if group x bar 1, it's just basically adding all this up and divided by total number of them. It's average in the group. It's group mean of the group. Okay. So there's nothing new but just definition. Now, I hope there's no problem. Just because this definition, whether you get it or not. Okay. Here we will call what we call sum of squares. Okay. And we have 3 of them: sum of total, sum of group, between group, within group, and there will be decomposition. Okay. So, and this is related to variance, which we will see in the next slide. This is numerator of the variance. Okay. If you do sample variance, right? This is just basically adding all observation, right? Go from group 1 to group C, from first to the last observation, you do n-1, right? This will be the variance. Okay. This is the numerator of the variance. Okay. So we call sum of square total, SST. So numerator of the variance. Okay. And later you will see I want to divide this into 2 parts. We call SSG and SSW. I know it's time, but give me 5 minutes. We'll quickly finish this because I want to show you the result. It's very, very quick, don't worry. So now this is SSG here. So SSG will be, basically you have group 1, group 2, and group 3, right? And for each group, you can have the mean of each group, right? X1 bar, X2 bar, right? And what you're doing here is you replace each observation by its group mean. Okay, just replace every observation by its group mean. And do it again, do the same thing, okay? Same as SST, but you just replace it by the mean of the group, okay? And later you will see why we do this very quickly. And here the SSW will be replace the overall mean by the mean of the group. Okay, what does that mean? So this is the variation of the total data, and SSG is because we replace each observation by its group mean, so there's no variation within group. Okay, so that's why I look at the variation between group, because within group the same idea here. You are looking at each observation, look at the difference between each observation and the group mean. Okay, so looking at the variation within group. Okay, turn out we prove in this regression chapter, which said total variation is the sum of the two parts, variation between group and variation within group. Okay, that's a very interesting result, but we are not going to prove it here, but this will be given to you now. So now just very quickly, as we have hinted, mean squares, you divide by total number of observation n-1, and MSG is SSG divided by number of group minus 1. We don't explain why this is the case. And MSW divided by n minus C. Why this is true? We don't explain why. We will be more clear when we do the proof. But the last line I want to show is, if you want to compare more than one group, the mean, okay, remember t-test will be just compare the two. Now you compare more than one group, what you would do is you do f-test and you compare MSG and MSW, but nothing but SSG, SSW, and the degree of freedom will be C minus 1 and N minus C. So that will be same as f-test. So that's what I want to say today. We'll talk about this again more, but I just want to give you this test. We'll go over it again next class together with proof. So have a nice weekend. I will stay around to answer any question that you might have. So bye-bye. Thank you. See you next week. I still want to answer any question you might have.
Hello.
Yes.
So I'm a lazy person and I find a way to do my homework. Let me show you. I don't know whether it is okay or not.
Okay.
Can you see my work?
Not yet. Just wait a bit.
Yeah, okay.
If it starts share screen, but I didn't.
Oh, this one.
Okay.
Yes. Can I do it like this? So I just copy the Excel with the formula here and there for sentence.
I think it's fine. I don't have any objection. Yeah, fine. It's fine for me. Yeah.
Thank you very much. Because writing a long paragraph with a lot of steps is quite time consuming, I think that.
Oh, I think that is fine with me. I think that's fine. Yeah.
Thank you.